All right, so we are going to talk about double angles currently. So recall that the sine of A plus B is equal to the sine of A cosine of B plus cosine of A times sine of B. Now we're going to replace both A and B with x. So every place A and B are, instead of writing A and B, we're going to write x. So we'll have x, the sine of x plus x. So then we'd have the sine of x cosine of x plus cosine of x times sine of x. So this is, we could simplify here, and so we see the sine of 2x will equal, well, these are the same. You know, they're written in different orders, but multiplication is commutative. It doesn't matter the order. They both have a sine times a cosine, so we can add them together. They're like terms. So we've got two of them. 2 times the sine of x cosine of x. So that's our formula if we want to find the sine of 2x. If we want to find the cosine of 2x, so recall that cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. So we're going to replace A and B with x again. So we have the cosine of x plus x will equal the cosine of x times the cosine of x minus the sine of x times the sine of x. And so we will see that the cosine of 2x, if we simplify the left side, will equal cosine squared x minus sine squared x. And we could modify this and get a couple of different versions using Pythagorean identity, but we'll just start with, that's a basic one of what we could use for cosine of 2x. All right, now recall tangent of A plus B equals the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. So again, we are going to replace A and B with x. So we'll have the tangent of x plus the tangent of x over 1 minus the tangent of x times the tangent of x. So if we simplify the left side, x plus x gives us 2x. On the right side, tangent of x plus tangent of x gives us 2 tangent of x. 1 minus tangent squared of x in the denominator. And so if we want to find the tangent of 2x, that's the formula we can use to do that. All right, so let's put some of these new formulas to work for us. So number 1, they're telling us the cosine of x equals 2/3 and that the sine is negative. So if the cosine's positive, sine's negative, we must be down there in quadrant 4. So we want to find the sine of 2x. Well, up above, we just found that the sine of 2x would equal 2 times the sine of x times the cosine of x. So that's step 1, writing my formula. Step 2, I'm going to draw my little reference triangle over here in quadrant 4. So if the cosine is 2/3, we have this, here's angle x. All right, so Pythagorean theorem, 3 squared is 9 minus the leg squared, so 2 squared is 4. So 9 minus 4 is 5, and we'd have to square root. And we know it's going to be negative down there. All right, so step number 3, we actually plug in the values. So 2 times the sine of x. Well, the sine of x would be negative square root of 5 over 3. And then cosine of x, they told us, was 2/3. So step 4, if I simplify that, if I multiply my tops, 2 times 2 is 4, times negative square root of 5 would just be negative 4 square root of 5. And the denominator, 3 times 3 gives us 9. So it's negative 4 times the square root of 5 over 9. All right, next one. So if the sine of x equals negative pi over 2, if sine of x equals negative 2/7, and cosine is also negative, we must be down in quadrant 3 if they're both negative. So if we want to find sine of 2x, again, our formula is the sine of 2x equals 2 times the sine of x times the cosine of x. So if I draw my reference triangle, I'm now over in quadrant 3. And so if the sine is negative 2/7, or Pythagorean theorem, 7 squared is 49 minus the leg squared, which would be 4, gives us 45. So square root of 45 is divisible by 9, so we can break it down as negative 3 times the square root of 5. So that's step 2, drawing our diagram. Now step 3, we'll plug in the values. So 2 times the sine of x, which is negative 2/7, times the cosine of x, which would be negative 3 times the square root of 5 over 7. So if we multiply that all together, the two negatives will cancel. 2 times 2, 4 times 3, 12 times the square root of 5. And in the bottom, 7 times 7 gives us 49. So it would be 12 times the square root of 5 over 49. All right, so if we want the cosine of 2x, so we have options for how to do this. So, cosine of 2x is equal to cosine squared of x minus sine squared of x. But remember, you could always replace cosine squared of x with 1 minus sine squared of x. And we already have a minus sine squared of x. And so we could do 1 minus sine squared, 1 minus 2 of the sine squared of x if we combine them. So that's just a modification of the original formula we found using Pythagorean identity. So if we replace this with 1 minus sine squared, we still have the minus sine squared. Since these are like terms the same, we can combine them and get negative 2 sine squared of x. So let's use this one, 1 minus 2 sine squared of x. We'll get the same answer no matter which version of the formula we use. But since they gave us the value of sine, we may as well use it. So 1 minus 2 times negative 2/7 squared. Well, if we square the numerator and denominator, we get 2 over 49. And then that would be negative 8 over 49. And we know 1 is 49 over 49. So 49 minus 8 over 49, we're going to get 41/49 for the value of cosine of 2x. All right, so the tangent of 2x, well, we know the formula there. 2 times the tangent of x divided by 1 minus tangent squared of x. So there's step 1, writing our formula. We already have our reference triangle up above, so we can go ahead and plug in the values. So using my reference triangle up here, tangent is opposite over adjacent. So the two negatives will divide out, and it will just be 2 over 3 times the square root of 5, and 1 minus 2 over 3 times the square root of 5 squared. So if we work on simplifying that, we will get 4 over 3 square root of 5 over 1 minus, the top would be 4, and the bottom we'd have 9 times 5, so 45. So 1 would be 45 over 45 minus 4 over 45 will give us 41 over 45. So if we multiply by the reciprocal, so 45 divided by 3 would give me 15. So 15 times 4, we'd have 60 over 41 square root of 5, but then we'll have to rationalize. So we would multiply top and bottom by square root of 5, so we'd have 60 square root of 5 over 41 times 5, but again, we can cross-reduce. These are both divisible by 5, and bring it down to 12 times the square root of 5 over 41. And that's what the tangent of 2x would equal. All right, number 3, if cosine of x equals negative 2/5 and we're in quadrant 3, find the tangent of 2x. So again, if we start by writing down our formula, so step 1, write down the formula. Tangent of 2x is equal to 2 times the tangent of x over 1 minus the tangent squared of x. Step number 2, draw your reference triangle. So we're down here in quadrant 3. So here's x, cosine is adjacent over hypotenuse. So 5 squared is 25 minus the leg squared, which will be 4. So 25 minus 4 is 21. So it'd be negative square root of 21 for this other leg here. So if we plug into our formula, the tangent would be negative square root of 21 over negative 2. So it'll just be square root of 21 over 2. And then 1 minus that squared. And then we simplify. So here, these 2's will divide out and just leave me with square root of 21. In the bottom, I've got 1 minus 21 over 4. Well, 1 would be 4 over 4, so minus 21. 4 minus 21 would give us negative 17 over 4. And so then if we multiply by the reciprocal, times negative 4 over 17, we're going to get negative 4 times the square root of 21 over 17. And that's what the tangent of 2x would equal. All right, so we're going to simplify each expression, evaluate the resulting expression exactly if we can. So when I look at this one, this is our tangent formula that we were just using. This is this. So whatever is in here, we just need to find tangent of 2 times it. So this is the equivalency of saying the tangent of 2 times 22.5 degrees. Well, 2 times 22.5 would be 45 degrees, and we know the tangent of 45 degrees equals 1. All right, so this is your cosine of 2x formula. So this will be the cosine of 2 times 75 degrees. So it's the cosine of 150 degrees. Reference angle there would be 30 degrees. So if you think about your special right triangle, 1, 2, square root of 3. Here's 30 degrees across from that shorter leg. So the cosine of that is adjacent over hypotenuse. So square root of 3 over 2, but we're over in quadrant 2, so it's going to be negative square root of 3 over 2. All right, so this is our sine formula. If we go back to sine of x, cosine of x. So x in this case is x plus 2. So we're going to have the sine of 2 times x plus 2. And so we will have the sine of 2x plus 4, which we can't evaluate because we don't know what x is. All right, so now we're going to use this to help us solve some equations. So if we have the sine of 2x equals 2 sine of x, let's first of all replace this sine of 2x with its formula, 2 times the sine of x cosine of x. And then I'm going to subtract everything to get it on one side. So I'm going to say 2 times the sine of x cosine of x minus the 2 times the sine of x, so that it all equals 0. So I'm taking this turn, moving it over to the left side. So because it's positive, I subtract it to move it over. Can't combine them because they're not like terms. And if I subtract it here, I get the 0. Now on this left-hand side, I know it's GCF. They both have a 2. They both have a sine of x. So if we factor out 2 times the sine of x, we'd be left with cosine of x minus 1. And all of that still equals 0. So I'm able to use my zero product property to say 2 times the sine of x could equal 0, or cosine of x minus 1 could equal 0. So over here, if we divide by 2, we get that the sine of x has to equal 0. So we're looking for which angles have a sine of 0. So we know that's the quadrantal angles over at 0 and pi. So those are the two angles that would produce a sine value of 0. Cosine of x minus 1 equals 0, so let's go ahead and add the 1 to move it over. So we've got cosine of x equals 1, so I've got to think about my unit circle or figure out where I've got a cosine of 1. Again, we're at quadrantal angles. If we want positive 1, that only happens at 0 radians. So x could equal 0 or pi are our only two solutions to that problem. All right, number 8. So the cosine of 2x, since we have sine here, Let's use the version that's all in terms of sine. So let's do 1 minus 2 times sine squared of x. So because this is quadratic, I'm thinking I want everything on one side to factor, and I prefer that leading coefficient positive. So I'm going to move this, I'm going to add it over there and subtract the 1. So that I will have 0 equals positive 2 sine squared of x plus the sine of x minus 1. Remember, think of this as 2x squared plus x minus 1. We can factor that. We know it's 2 times x. It's just that x in this case is sine of x. And then this would be 1 times x. And again, x is sine of x. And we know to multiply to 1, it's 1 and 1. We want the bigger product positive, so I want that there. So that when we multiply this, we'll get 2 times the sine squared of x. 2 sine of x minus 1 sine of x gives us 1 sine of x, and the negative 1. So again, zero product property, set each factor equal to 0, and solve. So 2 times the sine of x equals positive 1 when we add it over. Divide by the 2, so the sine of x equals 1/2. So if you want the sine of x to equal 1/2, use your special right triangle. We have one drawn up here. So for the sine to be 1/2, it would have to be this angle. We'll just cross from the smaller side. So that's our 30 degrees, or pi/6. Sine is also positive over in quadrant 2. So pi/6 or 5 pi/6. For this one, I subtract the 1 to the other side. So I want to know, when does sine of x equal negative 1? Well, that's a quadrantal angle down at 3 pi/2. So x could equal pi/6, 5 pi/6, or 3 pi/2. There's 3 possible x values for that equation. All right, so number 9. All right. This time, I want everything in terms of cosine. So let's take, we know that the cosine of 2x, we talked about up here, equals the cosine squared of x minus sine squared of x. So let's go ahead and replace the sine squared of x using the Pythagorean identity. That's 1 minus cosine squared of x. And so if we simplify, we have cosine squared x minus 1 plus cosine squared of x, because we just got to distribute the negative to this and to that. That's why this becomes a plus. So if we add these two together, we get 2 cosine squared x minus 1. So that's the third version we could use of that cosine of 2x formula. And that's the one I want here, so that it's only in terms of cosines. So I'm going to keep the left-hand side for now, cosine squared x plus cosine of x. And I'm going to replace the cosine of 2x with 2 cosine squared x minus 1. And so now I'm going to subtract to put everything on one side. So I'm going to move this to the right-hand side, because it's quadratic, so I need everything on one side. So I will have 0 equals positive cosine squared of x minus the cosine of x minus 1. And so remember, think of this as x squared minus x minus 1. That's not factorable. I cannot multiply to -1 and add to -1. So we aren't able to factor this. We've got to use another method. Can't use square roots because of the linear term. So we're going to use quadratic formula. Totally was going to say the wrong thing there. We got to use quadratic formula. If we have a quadratic that's not factorable, can't use square roots because of the linear term. And we don't want to try and complete the square here, because remember, what we actually have is the cosine of x. So we're going to use a little substitution here. So we're going to introduce a replacement variable here. There we go. All right, so we're going to say let u equal the cosine of x. So then we would have 0 equals u squared minus u minus 1. So in why do I keep saying that today? I'm sorry. In quadratic formula, we have the opposite of b would become positive 1 because b is the coefficient of your linear term. So b is negative 1. So it becomes positive 1 plus or minus the square root of that b value squared minus 4 times a times c, all of it divided by 2 times a. So negative 1 squared is 1, negative 4 times 1 times negative 1 gives us positive 4 all over 2. So we get 1 plus or minus the square root of 5 over 2. So that's what u would equal. Now we have to think about things for a minute. So u is actually cosine of x. And if we would do 1 plus the square root of 5 divided by 2, that's going to be bigger than 2. So we're going to have something bigger than 2 divided by 2. It's going to be bigger than 1, which means we can't use it. So we can't use 1 plus the square root of 5 over 2 because that's bigger than 1. So we can't use it because it's greater than 1, and cosine is always less than 1. Same with sine, because remember, cosine is the adjacent side over the hypotenuse, and hypotenuse has to be the longest side of the right triangle. So you're always going to have the biggest value in the denominator, which means the value of the fraction is less than 1. So we toss that one out. We can go back. U was the cosine of x. So now we know the cosine of x has to equal 1 minus the square root of 5 divided by 2. And so if we type that into our calculator, so we'll type in our calculator inverse cosine of 1 minus the square root of 5 over 2. There we go. Sorry. Couldn't quite get it to move at first. Okay. So I'll do second cosine to bring up the inverse cosine. And then I need my fraction bar. 1 minus second x squared to get the square root divided by 2. Oh, let me check my mode. I need to be in radians. So let me switch my mode back to radians. Try that again. Okay, so we get that x is approximately 2.24, which is quadrant 2. But the other place that it would be negative is quadrant 4. So what I need to do is so figure out pi plus the reference angle. So first of all, so pi minus this will get us our reference angle that we then need to add on to pi to get our second angle. Down in quadrant 3. So if it was 2.237 in quadrant 2, what I knew was that in quadrant 2, our reference angle is pi minus that. So I took pi and I subtracted that to see what the reference angle was. And then to put it down in quadrant 3, I do that plus pi. So there are my two values, one in quadrant 2 and one in quadrant 3, because 1 minus the square root of 5 over 2 is negative. And if we want cosine to come out negative, it's got to be down there in those two quadrants.